Alright, so like obviously, you know, I've become intimate with this integral, and so, you know, like I know not just every step of the solution, but how to write and all that good stuff, yeah? Okay. I want to make sure my line is straight. Okay. Alright. So what we do to start is like, oh yeah, let u equal e to the x, right? So du, ooh, is this in your line of sight? Hold on. I might be writing off the board. Nah, I'm straight. Okay. Du equals e to the x dx, right? So then that means that dx is equal to du over e to the x, but e to the x is claimed as u here. So we'd be like, this is u. Alright, cool. So then the integral becomes, it's not narrow. The integral becomes u minus 1 over u plus 1, and then it's square root u. My u's and my n's look the same. My bad. So u, and then plus 1 over u. Yeah, because e to the minus x is 1 over e to the x, but that's 1 over u, and then plus 1, and then du over u, right? Because dx is du over u, right? Okay, and then what we're going to do is we're going to be like, oh yeah, this is square root of u squared, right? And so then using square root properties, we're going to throw this u squared in here. So it's going to multiply all of these guys. It's going to multiply this, it's going to multiply this, it's going to multiply that, right? Okay. Shoot. Eraser. I have more math than I need, so. Oh yeah, it's right here. Hold on. So again, that u squared is going to go in here, right? So then this is going to become a u cubed. So this is u squared over u. That's just u. And then this is u squared. So I'm going to write them in order. I'm going to put the u squared in the middle. And the other fella is plus just a u, right? Okay. Alright, and so this is the next clever trick that we must enlist the help of. I want to like trying to color code it. And that is multiply numerator and denominator by u plus 1. And so u plus 1 right there. And obviously there's already a u plus 1 right here. So what it's going to do there is it's going to square it, right? Okay, cool. So then next, you see that this is the same as this here using difference of squares is u squared minus 1, right? Over. And then here, u plus 1 quantity squared using the binomial square is u squared plus 2u plus 1, right? And then we've got this fella right here, right? And then so square root of u cubed plus u squared plus u, and of course monsieur du, right? Okay. All right. Whew. Let me catch my breath. I've done this before. Just kind of lame, but all right. So where to next? Well, what we're gonna do next is we're going to multiply both the numerator and the denominator by 1 over u squared. 1 over u squared. So when we do that, what we're going to get here is this here divided by u squared. Again, we're going to multiply numerator and denominator by 1 over u squared. So here we get this divided by u squared. And like, I really wasn't interested in making an integral today, but I wanted to keep my promise of doing it by Sunday, as I told Ernest. So, you know, since he labored hard at helping me with this integral, so I want to keep my promise. So again, I multiplied both numerator and denominator by 1 over u squared, and so that meant that here I have divided by u squared, and here I have a u here and a u here, which together make, well, 1 over u squared, right? Okay. Alright, so just like we kind of did in this earlier step, what we're going to do is we're going to sneak this u squared into the square root by writing it as the square root of u squared. And so here we're going to divide each term by that u squared, and in the numerator we're going to divide both of the terms by sorry, that's a u, not a u squared. So we're going to divide every term here by u, and then here we're going to divide the two terms by u squared. Jesus Christ, I can't breathe. Like this mask. Okay. So all right. So dividing both of these terms by u squared in the numerator, we're gonna get 1 minus 1 over u squared, right? And then all of this divided by here. I said we're gonna divide each of the terms by u. So we're gonna get u, because that's u squared over u, and then plus 2 plus 1 over u. I'm going to choose to write the 1 over u in the middle. You'll see why. And then plus 2, right? Okay, this is a flawless presentation. Ernest, thank you for the help though. Okay. Because everything is deliberate. Right? Okay. So putting this u squared in here, right? Together under 1 square root, right? So like I'll do it right here. Okay. So we have like this, and then right there. Yeah? Okay, so just as I've done here, I'm going to divide each of the terms by u squared. So when I do, u cubed over u squared is going to be a u, and then u squared over u squared is 1. But then we get u over u squared, that's 1 over u. So I'm going to write the 1 over u in the middle, plus 1 over u. You see? And then u squared over u squared is 1. Yeah? Okay, cool. And then du aq, right? Okay. Alright. So now what we're going to do is we're going to claim this right here, the square root quantity, we're going to claim it to be t. Well, any other variable if you're choosing other than an x and a u. Alright, so if we call that t, then notice that t squared is going to be equal to u plus 1 over u and then plus 1. Right? And so then we take the derivative of both sides here, and we're going to get 2t dt is equal to 1 minus 1 over u squared du. How convenient. Because this here, right, becomes, I don't like that I wrote over it. Can I undo that? Okay. So this here is going to become 2t dt. Right? Right? So that will replace both this and this, right? And also, notice that this here, u plus 1 over u plus 2 is u plus 1 over u plus 1 plus 1. So it's t squared plus 1. Again, flawless delivery, right? 1 plus t squared. Okay. Sorry. I'll stop writing. Okay. And this here, I already claimed as t, right? Oh, look what we could do. We have a t here in the denominator and a t there. So then all you have is coffee left. Okay, so 2, and then I like the motorcycle gangs. They're a little noisy, but they're cool. So I took the 2 out. That's that 2 right there. And then otherwise you have dt over 1 plus t squared, which is called math people's favorite antiderivative. Like, although it's basic, and that's 10 inverse. So we have as our final answer 2 tan inverse of t plus 1, right? But wait, what was t? T was the square root quantity, but in it is some u, and u is e to the x. So our final answer is going to say 2 tan inverse of square root of e to the x, right? And then e to the x was the name of my very first business, and someone cheated me out of it. It's just sad, but whatever. It was like a nice learning experience. Plus e to the minus x plus 1, and Christ didn't mean it, obviously, for me. All right, there we go, and I'm sure he got him. Get him.